So here's an example of a question using straight line motion about speed, distance and time. So I've set up a situation where two students are having a highly unethical spider race, and they've set up an 80 centimetre track. You can see here I've just labelled it ABC for convenience. And then we're told some stuff. First of all, Spider A took 2 minutes to complete the course. Find their average speed. Now we know, of course, that spiders, being spiders, it's just their average speed. It's how much they did over the whole course. You can't expect to be able to work out their speed at any given point, their instantaneous speed. So it's their average. If they were moving constantly, how fast would it be? So as with any type of mathematical problem like this, let's write down the things that we know. We know the distance of the track was 80 centimetres, and we know the time was 2 minutes. Now at this point here, we should be seeing a trap that's been set for us. And in our case, the trap is that these are not the correct units. If we work this out now, if we do V equals D over T and we work out, they travelled 40 centimetres a minute, that's true, but it's not correct. If you do that, you're not getting the proper answer. You've got to convert 80 centimetres into 0.8 metres, and you've got to convert 2 minutes into 120 seconds. So now we write down the formula that we're going to use. V equals D over T. We substitute in what we've got, 0.8 divided by 120, and that works out to be 0.007, well it's actually got a few more decimal places, metres per second. That is about 7 millimetres a second. Okay, and that's a pretty reasonable answer because they're spiders. So now let's look at this one here, a distance time graph. Remember, distance up the vertical axis, time along the bottom, metres. So you'll see there I put distance and I put metres next to it, and set time, seconds next to it. Compare their motion throughout the race. There's a couple of ways of doing this. In your exam, it's completely acceptable to just write on the graph like what you can observe. So if you just wrote on next to it, constant speed, these little flat sections were rest and these were constant speed again, that's pretty good. Remembering that this here, if we consider this, see the spider is changing their distance, so they're getting further away from the start line over time. That means they're moving, they've got constant speed. They're doing it evenly. So for every little chunk of time, they're taking the same little chunk of distance. That's what we mean by constant speed. In this section here, you can see time's passing, but they're not moving. So time's passing, but their distance isn't changing, they're at rest. But we've been asked to compare their motion. So you might want to say at first. That's a completely acceptable way to start your answer. If you don't like writing whole paragraphs or sentences, it's fine to do bullet points as well. But at first, and I haven't called them A and B, but I'm going to call them green and purple. So at first, purple spider has the greater speed or velocity. And we know that because the slope on the distance time graph is faster. It is covering a bigger distance in the same time. If you look here, this one's covered half the track in 50 seconds. This one won't cover half the track until 60 seconds have passed. Okay, so this one must be travelling at a faster speed. So at first, purple spider has the greater velocity. Okay? It then rests, and you can put there, it doesn't move, or clarify it. It then rests from 70 seconds to 120 seconds. And it's fine to write that if you want, the exact times. Okay? Green spider has a lower velocity but only rests for 10 seconds. Okay, therefore it reaches the end faster, okay, in less time, or perhaps even first. Therefore, it finishes first. Okay, and therefore has the greater average velocity than spider B, than purple spider. It has the greater average velocity, even though we can see, looking at it, that purple spider had a faster velocity at first, but then it rested, so it took longer to complete the course. So this was quite a complicated example, but the chief things you need to look at are two. One, make sure you convert centimetres into metres, kilometres into metres, millimetres into metres. Minutes and hours have to be converted into seconds. In a distance time graph, if you see an area with a straight gradient, a straight slope, that means constant velocity. The steeper the slope, the faster the velocity. If you see an area that is flat, that means it is at rest during that time. If you see an area where the gradient is curved, that means it is accelerating. So I haven't shown one on this, but you need to just remember, if the gradient is curved, like if this was curved instead, it would be accelerating, starting, changing its velocity, changing its distance slowly, then changing its distance faster and faster and faster.